In this video, we'll discuss converting between bases. Now, it's first to understand the notation if a number is not in base 10. Whenever this occurs, we're going to write the number often with parentheses and then a subscript of that base so we can distinguish it from base 10 numbers, because base 10 numbers do not require a subscript. So if I see in parentheses 463 with a subscript of 8, I know that would mean the number 463 in base 8. Whereas if I see 578 with nothing, that's going to tell me that's 578 in base 10. Now, when I'm doing these other bases, I want to look at what are my numerals. If it is a number with a base less than 10, we're going to use our standard numerals like we do for any other base 10 problem. It's when we have bases that are greater than 10 that we have to pay attention. In this case, we're going to have to make a single digit numeral for 10, 11, up to the base itself. So we do want to pay attention to that. Now, if we're starting with a base 10 number and we want to convert to another base, the first thing we're going to do is determine what's the greatest b to the n power that's less than our base 10 number. That's going to help with the conversion. And remember, you start with b to the 0, which is 1, and we go consecutively from there. Well, we're going to start then with our greatest power, and we're going to divide our base 10 number by that. Typically, it's going to give you a remainder. And then we're going to go sequentially from our greatest to our least power, dividing and always dividing the remainder until we're all the way down to the point of b to the 0. We never skip a place value. Even if the value that we're dividing by will come out to 0, we need that because that 0 represents a place value. So don't skip any of your powers. Let's look at the example of changing 468 to base 7. No parentheses, so we recognize that as a base 10 number. So let's look at that base 7. If I look at base 7, b to the 0 would be 1, b to the first is 7, b squared is 49, b cubed is 343, b to the fourth is 2,401. Well, that's bigger than 468, so I can't use that. So my greatest b to the n is going to be b to the third. So I'm going to start by taking 468 and dividing by 343. That can be done one time and has a remainder of 125. Now I take my 125 and divide by the next base, which in this case is 49. That can happen twice and leaves me with a remainder of 27. Now I take 27, divide by my next base, which is 7. That happens 3 times with a remainder of 6. And now I take 6 and divide by my final base, which is 1. 6 divided by 1 is 6. And now I can look and say that the number that converts into base 7 will be 1,236 base 7. Now what if I want to go the other route? I want to convert from a base to base 10. What I'm going to first do is change the number from its decimal form, or that positional numeral form, into its expanded form, or its multiplicative grouping form. So to do that, I have to pay attention to my base and the exponents. Your greatest exponent is always n minus 1 if you look at n being the number of integer base digits in the number. And also remember, you need the ones place, which is b to the 0. And that relates then to the n minus 1 being your greatest power. Once we have it written in expanded form, we can simplify that expression, and that simplified number will be in base 10. So let's take what we had before, 1,236 in base 7, and convert that back to base 10. Again, we recognize that this is in base 7. So that means that we're going to be doing 7 raised to the powers each time. So I start with my greatest, which is 1 in the 1,000, so that's 1 times 7 to the third, because there's 4 digits, 4 minus 1 is 3. Then 2 times 7 squared, 3 times 7 to the first, and then 6 times 7 to the 0, or 1. I then would simplify each of those and then add them together, and that'll take me back to 468, which helps reinforce that how did I convert from base 10 to base 7, and now converting base 7 back to base 10. It's the same number. The last thing I can do is convert between any two bases. The first thing I do is I'm going to take my initial number, convert that to base 10 like we just did, and then after I've done that, I'll take my base 10 number and convert it to the desired base like we began. So The big thing to always pay attention to is that we never skip a place value. Always go consecutive whenever we're doing these problems. So let's say we have the number 467 in base 8, and we're going to convert that to base 4. So we're starting, the first thing is to convert from base 8 to base 10. So I'm going to take 4 times 8 squared, 6 times 8 to the first, and then 7 times 8 to the 0. I simplify each of those and then add them together and see that that's going to be 311 in base 10. But that's not the base I want for my solution. I want it in base 4. Now I can say let's convert 311 to base 4. So let's go through our base 4 powers. B to the 0 is 1, b to the first is 4, b squared is 16, b cubed is 64, b to the fourth is 256, and then b to the fifth is 1024. Well, that's too big, so I'm not going to use that one. My greatest power is 256. So I'm going to start by taking 311 divided by 256. That's 1 with a remainder of 55. Now I'm going to go to my next power. I do not skip any place values. So that's 55 divided by 64. That's not possible, so that's a 0. But a 0 is important. It's a place value. I still have a remainder of 55. Now I can do 55 divided by my next place value of 16, which is 3 with a remainder of 7. Now I can take 7, divide by the 4. That gives me 1 with a remainder of 3. And now I can take the 3, divide by 1 to get a remainder of a value of 3 there. And that tells me that when I started with 467 in base 8, that's 10,313 in base 4. That 0 was important. It tells me a thousandths place in base 4. So do not skip any of your place values. It will be immensely important.